Good morning. If everybody can take their seats, please. Welcome back to day 2 of the InnovationXLab Summit. I hope you all had a good evening and got to meet some additional people. Today's program is just really exciting. I think we had a great program yesterday, and I think we're going to close the summit with a bang because there's a lot of interesting speakers and panels today. Today's program begins with opening remarks from Paul Dabbar, who's the Undersecretary for Science. And joining us today is, to introduce the Undersecretary, is Johnny Moore, who manages the O&L site office. And Johnny is the manager of a large enterprise here at the Oak Ridge campus. And he manages contracts for Oak Ridge and the Oak Ridge Institute for Science and Education and others. His extensive experience in managing the operations at DOE facilities is a valuable asset to the department and to the laboratory, and we're very grateful for the partnership we have with him. Please join me in welcoming Mr. Johnny Moore.
Thank you, Michelle. It's my privilege to be here today. Yesterday, the proceedings were very interesting and exciting. And I think today there's many good topics this morning. You're going to hear about talent development, entrepreneurial economy and advanced manufacturing and accelerating technology transformation and commercialization, to name a few. At O&L, as the Secretary was talking about yesterday, workforce development is critically important. And we worry about STEM education. In both the laboratory and ORISE, there are many programs partnering with schools, community groups, science fairs, career fairs, professional development of teachers, other educational development programs that happen here. There is also a traveling science fair. Here locally in Tennessee, as liability and issues about bus drivers and accidents and injuries, there's been a transformation over the past 10 years or so for those to be able to go on field trips and to be able to come to the laboratory, come do other field trips, and the laboratory has a science fair which provides opportunities with the trailers to be able to participate in many science demonstrations and projects to go to the school system, to go to the community. We also host the Tennessee Science Bowl, which is the third largest regional competition. So O&L and all the national laboratories are dedicated to shaping tomorrow's workforce through opportunities in our system. So that's very important. It gives me great pleasure to introduce our next presenter. Beginning his career as a nuclear submarine officer, both at Mare Island and Pearl Harbor, including deployment to the North Pole, where he conducted environmental research. Mr. Dabbar served as the Department of Energy Environmental Management Advisory Board. He's been a lecturer at the U.S. Naval Academy, conducted research at Johns Hopkins Applied Physics Lab, and a member of the Council on Foreign Relations. And prior to his confirmation as Undersecretary for Science, he worked in operations, finance, strategy roles in the energy sector. And as a managing director at J.P. Morgan, he led various energy business areas, has over $400 billion in investment experience across all energy sectors, including leading majority of all nuclear transactions. The Honorable Paul Dabbar, the Undersecretary for Science, serves as the department's principal advisor on fundamental energy research, energy technologies, science, driving this mission through programs including nuclear and high energy particle physics, basic energy, advanced computing, fusion, biological and environmental research. He also provides oversight of environmental legacy management and direct management over a majority of the department's national laboratories and their world-leading user facilities. Please join me, he's also my boss too, but please join me in welcoming Paul Dabbar. Thank you.
Well, thank you everyone for attending our third XLab event across the lab complex. And it's really exciting for everyone here, certainly for myself and hopefully for everyone here, for increasing the connectivity between the National Lab Complex and what we're doing along with our university partners across the nation, what we're inventing in our research strings, and the possibilities and how to move it out the door. I spent a lot of time up on the Hill with people who look at investing the taxpayers' money into research strings across the complex. And it's important not only for research to be able to drive new knowledge, but when that new knowledge that can be applied to move the American economy, to create jobs, to take regions and drive them forward, that's an important part of what we should be doing. And this is a part of how do we increase communication across the complex and throughout the country. This is a particularly exciting time in terms of various things that are going on. For those of you who were here yesterday, early in the morning, we announced right here on Frontier, which is yet again the next top-end supercomputer in the world. I was joking with the secretary if he was getting tired of making supercomputing announcements, the secretary, and he said no, he's not tired of it. And today, just this morning, was another announcement. You probably didn't catch it, but I want to go ahead and make it here today. The department just announced with ExxonMobil for a $100 million research cooperative agreement in which ExxonMobil is going to be investing $100 million of its own dollars into the National Lab Complex, led by NREL and the Renewables Lab and the Fossil Lab at Nettle in Pittsburgh and West Virginia, on a whole string of research in the energy sector. The fact that we have yet another and obviously $100 million investment in research by one of the largest energy companies in the world on where to drive research is a wonderful partnership. And speaking a little bit from the lab complex, the fact that a private company is investing $100 million of its dollars to invest in research in our lab complex can only be done because of the confidence of someone who's at the high end of knowledge, obviously, around energy and energy technologies, feels that the National Lab Complex has capabilities that it wants to fund with its private money. Goes to show you the capabilities that we have and the possibilities that if we increase communication, what more can be done. So that's a very exciting announcement, and congratulations to our friends at NREL, who certainly spearheaded this dialogue with ExxonMobil and Nettle, and there's also work with INL that will be there, Idaho National Lab. When the secretary, I think for those of you who heard him yesterday, came on board, we knew that we were stepping into a department with a great deal of history, and the history is deepest here at Oak Ridge. For those of you who are familiar, obviously, about the National Lab Complex, that it started with the Manhattan Project, and the role of the men and women here at Oak Ridge and across the complex. For those of you who may not know, obviously there's many people here with a lot of history in the lab complex, but I do want to talk I want to spend about 5 minutes and talk a little bit about the history of the lab complex to put it in perspective of how we got to where we are here today, because I think there's many people here who don't have the full scope. The National Lab Complex has today over 60,000 people who work in the National Lab Complex. It is the largest R&D organization in the world. It is the largest generator of Nobel Prize winners in the world. People who've done work over the course of their career that ultimately led to Nobel Prizes. This is something that is not well known in the United States in terms of the scale of what the National Lab Complex is today and what it accomplishes. A little bit of the history for it that puts it in the context, but I think it very much fits into the topic of this particular XLab around materials and advanced manufacturing. So the lab complex was effectively, at least from my point of view, started by a recommendation from Albert Einstein. And for those of you who are familiar with a little bit of the history of physics in the national labs, was that it was actually a Hungarian scientist. There was a number of people who were fleeing Nazi Germany and fascism in the physics area, in the chemistry area, the materials area, who came to the United States. And a gentleman by the name of Szilard from Hungary was amongst them. And he was the one who pointed out that Heisenberg and others in Germany were working potentially on fission, doing fission on uranium, that could produce a reaction that could produce a weapon. And so Szilard wrote a letter that he wanted to send to President Roosevelt, but he didn't think the president would notice his name. So he convinced Albert Einstein to sign the letter, and it was sent to FDR, signed by Einstein, and I have the letter, copy of the letter up in my office. The secretary has a copy too, in which they recommended that the federal government work with the physicists and other scientists in this particular area, because this is really important, and it could have a material impact on creating a weapon. And that letter from Einstein started the Manhattan Project, started at Columbia University and moved elsewhere in Manhattan. And then they kind of figured out that maybe doing this was probably not a great idea to do it in New York City. And they moved to Oak Ridge as the first of the places. And so that's how the lab complex started, was pulling together material scientists, chemists, physicists, the greatest minds literally of the world that had come to the United States because of what had been going on across the world at that point in time. And the lab complex was created around solving a problem. And I think from those of you from an academic community point of view, a lot of times when you look at universities, I think things are very much changing in the university system. But historically, when you look at universities, there was a department in computer science and a department in life sciences and a department in math, and many times they didn't talk to each other about joint projects. I do think those things are changing in the university system. But the National Lab Complex created a culture in the 1940s here at Los Alamos and at Hanford around goals. And it didn't matter that it was a Department of Material Science, or there was no Department of Material Science at Los Alamos or here. There was no Department of Physics. It was that there was goals to be achieved, and how do you bring people together? And so the wonderful part, as the Secretary talked about the National Lab Complex, is not the big user facilities, although I think lab directors love large user facilities. It's actually the culture and the people, as the Secretary was talking about yesterday. And that came from the culture of solving a problem during World War II and bringing people from different backgrounds together and how to go solve it. And that's what I think is special about the lab complex. And I do think we're a little bit of a beacon to the university system about how different departments can work together to solve interesting things going forward. And we're certainly seeing a lot of that change in the university system here today. And obviously this National Lab Complex became the core of what was the Department of Energy, and bringing a little bit forward about to where we are here today. At the time, and the Secretary talked a little bit about this, the 73 oil embargo, there were gas lines. I was growing up in Oklahoma at the time. There were gas lines in Oklahoma. Obviously, there's something wrong. And President Carter, who went to the Naval Academy like myself and is far more successful than I am, his solution to this was that there wasn't going to be enough energy. If you remember the sweater speeches, or for those of you who are old enough, one after another of sweater speeches in which he said we need to find an Alaska every 9 months, or a Texas every year to find energy, and we're not going to do it. And therefore we should figure out how we make do with less. And they started passing laws to restrict energy usage, restrict the use of natural gas. So there's a number of things that they passed around restrictions. And then he formed the Department of Energy around the National Lab Complex as a core to try to go help kind of pull a lot of this together. Well, the solution turned out, as we all see here today, was not about restrictions. The solution was about innovation. And where we are here today in terms of the cost effectiveness and the availability of wind, solar, batteries, oil and gas production costs, right? #1 producer of oil and gas in the world. Okay, I'll say that again. We're the #1 oil and gas producer in the world. By the way, that's severally. We're the #1 oil producer in the world, and we're the #1 gas producer in the world. And so this just happened in the last few years because of American innovation. And by the way, throughout all of that, the reduction in emissions, the leader in the reduction in emissions in the world is the United States. And as a side point, the #1 increaser in emissions in the world is China, and they're increasing their emissions at 3 times the rate that we're reducing. So these are just facts. And so it is an extremely exciting time about what the National Lab Complex has done and what's accomplished, and what can accomplish going forward. You know, there's some exciting things that have happened here in the past. The Human Genome Project was started at a DOE national lab at Lawrence Livermore. Many people don't realize that basically a lot of what's happened in genomics was started at the National Lab Complex here. The white LED light, nuclear power, nuclear medicine, nuclear imaging, the MRI machine, I could keep going on. One of the key parts, and this is a little bit about, you know, the subsets I kind of talked about, which is applicable to here, is around materials. So throughout all of this research, materials science, materials engineering, and ultimately the applicability of materials, whether it's here, whether it's at Berkeley, whether it's at Ames or across the complex, is a core part of what I just kind of described. And everything around advanced manufacturing and process has been fed by our knowledge and research into materials that feeds into this, which once again started at the very beginning when Groves and Fermi and Oppenheimer were doing their original work across the complex. A little bit about, and I think the Director Zachariah was talking to Secretary a little bit about this. Many of you may not have noticed, but there's been a significant increase on the part of Congress and President signing last two budget bills of a significant increase in research for across the federal complex. And so in particular, in the last year, as was mentioned yesterday in a sit-down, that the support for the Office of Science and across the lab complex is up almost 25%. It's a significant increase given the scope of where we are at Brookhaven, Oregon, and here in Los Alamos, and so on, PNNL. It is a significant increase. And I think what's happened here is that there's a general consensus about, and there's people who have different views about why they're interested in this, but there's a common denominator about it's important for the country to invest in science, in research, for economic competitiveness, sometimes for international competition. There's a lot of different drivers that people have. Some people are more focused on one versus the other. But I think there's a commonality that has clearly come up about the focus on that. And this year there's yet again additional support for even additional higher levels than last year that we see a senator here proposing, senator from Illinois proposing. There's a number of those floating around. And there's very exciting things that are going on. There's very exciting things that are going on here, which I'll talk a little bit more about. But what's going on at the National Institutes of Health and their increased funding around applications of genomics to, they think they may have solved sickle cell anemia, right? And these are crazy sort of things that people didn't know that they may have done. I was just with a NASA administrator at the White House here yesterday. You may not have followed it; it's public, but they are purchasing components to put up the Moon space station called Gateway. That is the first step that will be dropping down people and components to the permanent moon base. They are purchasing equipment. I'll say that again. They're purchasing equipment right now to get the manned moon base up and running, right? So that's something else that's going on right now. I could keep going about the federal footprint, but it's I think a very exciting time that we see here. When I look across, what's going on in science and research, and what can have a real impact on changing humanity. And I do think science and research and ultimately technology, I think there's a number, at least from the way I've kind of laid it out, is that there's 6 key areas of research that are going on right now that I think could have a dramatic impact on humanity and where we're going. And so the 6 I see in front of us are artificial intelligence and machine learning, quantum technologies, advanced and sustainable energy, space exploration, and space into universe exploration, mobility, advanced mobility, and genomics. So if you stop and think about each and every one of those areas, you look at where things are going in genomics, where are things going in advanced and sustainable energy, where are things going on AI or quantum You could, what's being discovered is seemingly on a monthly basis in space and universe exploration with the latest picture of the first black hole. That there are amazing things in front of us. And I get questions sometimes, is there more to learn? I go like, what we know about the universe and how it works is a tiny, tiny, tiny fraction. We don't have really any real idea about how the universe really works in terms of what's really out there at the end of the day. And so the US government and the federal complex, along with our university partners, are increasing support. And it's a very exciting time, I think, to be a part of this. And I think hopefully everyone at the lab complex and people interact kind of see that. So jumping forward to where we are here today for this particular get-together, one of the things that when the secretary, the deputy secretary, myself, Undersecretary Menzies, all of us came from a background of partial government service and partial private sector engagement. And it was actually an important part when the secretary was talking about putting together a leadership team. He said, I want people who have a background of both. And in part, it's because of the topic of this particular conference, right? It's importance around funding and supporting research. And it's not about moving dollars away from research or shifting dollars, but it's how do you make a greater set of connections for the research strings that we're given, that we're working on, that could have an impact. And I'm always very balanced from this point of view. There's some things that we do that is pure discovery science, right? So what's happening at Brookhaven on recreating the Big Bang at 1 × 10⁻⁶ seconds after the formation of the universe. I'm not quite certain that that's going to have any applicability anytime soon. But some of the same technologies that are being used to create those sort of experiments or research strings have applicability in quantum technologies today. And that came out of something that, to some degree, wasn't really fully expected. But when the people who were working on the facilities that we're building at Brookhaven or at Argonne or others across the complex, they started saying, wait a minute, we could use this for something else. And our ability to jumpstart a whole industry area is in part, in very large part, driven by the fact that we've invested in discovery research. So jumping forward is how do we make the connections that are things that we're working on that could have a commercial application? And so we are not, ultimately, we are not a development organization. We're not here to create industries, right? The department is, to a very large degree, just a very large research organization. And so how do we make those connections of what we're working on with the private sector? And once again, some things are, may not be applicable to the commercial sector because there's not an economic reason for it to work, currently in the market. But there are many, many things. And when you think about the more than $11 billion in non-defense R&D that we spend across the complex and the 60,000 people across the complex who work on various things, we are content heavy. That's an understatement about how much that we're creating. And one of the challenges is in a very kind of traditional academic setting, in large part, the National Lab Complex is like a very large university system. It's a little bit, and myself, it's a little bit like being a chancellor of the UC system with a whole bunch of universities, 7 universities, or in this case 17. And each one kind of doing their own thing and sometimes working together and sometimes not. And the National Lab Complex is somewhat similar. And historically, in an academic setting, how do you communicate what you're doing, right? You write papers. And I know that most of the people here in the commercial sector are not sifting through all the papers being produced by the National Lab Complex. By the way, I only know one entity that does that. We have this one entity in this country who actually sifts through all the National Lab published papers, and that's Google X. So they can afford it, I guess. They go through about 400 papers a month in the National Lab Complex. But they're a bit unique in order to have the resources to do it. And there's probably some additional communication abilities to try to connect. So one of the things that when the secretary and myself and the deputy sat down was, well, what are things that we could do? And one of the challenges with people working with the National Lab Complex is how to make connections. And many times historically it was, I'm in storage, I am in New York, I'm going to sit down with Brookhaven. When in reality, there's I think the number is about 11 different national labs. You all work on different storage in different areas and different chemistries and so on. And so there was an inefficiency that we saw in the system of people making connections that were a bit ad hoc and maybe one lab-centric reason. When in reality, multiple labs do different research, but in the same research string, the same topic, in materials, as an example. And so getting all the labs together and bringing a new group of people in terms of connections or an additional group expanding upon it. So not just universities and labs, but also capital, entrepreneurs, larger companies, end-use customers of whatever the topic was. So the first one we did was, and we were just picking on the areas that we decided to do these conferences based on areas that we have a core competency in. So the first one we did was in storage. Obviously, lab complex is a leader in chemistry, leader in applications of chemistry to things such as beyond lithium-ion batteries that have the potential of having performance metrics 3 to 5 times current lithium-ion. So when you think about an industry and say, we could have something that's, well, it would be the inverse of 3 to 5, cost advantage because of materials or other performance metrics around cycle life and so on, that would have a dramatic impact on how a car would work, right? Or how your personal electronics will work, or how a utility system would work. The second one we did was in grid technologies, and the third one here is obviously, as you've been hearing about, has been in materials science, and ultimately the application thereof of manufacturing. So there's a number of examples that I think have been talked about here today in the area of advanced manufacturing and materials. I won't go through all of them, but obviously there's a great set of examples that has been laid out here by the team in terms of, as I would call, the petting zoo out front of the various pieces. Except it's, it's concrete and steel instead of bunnies. In terms of the sort of things that are going on, and whether it's in manufacturing of components that can be a lot faster and a lot cheaper in the energy sector, such as out front on the hydroelectric side, or it could be done for boats or buildings, and working with architects in New York City around architecture topics, or more broadly applications. One of the exciting things that I see on a couple of other examples that are not out front is this application is really moving forward for real use in a number of particular areas. I'll give 3 of them that I've seen personally. First of all, General Electric is already using 3D printing on metals for certain plane engine components. And so it's already part of a production line of a first part for GE. The second one I'll give you is at SpaceX. Anyone here been to SpaceX manufacturing plant in Los Angeles? Okay, I've got one, a couple. So they are obviously at the cutting edge of being able to drive America forward and returning to space and the moon and ultimately Mars, which, by the way, National Lab Complex, including here, does a lot of work with NASA on how we're going to get people to Mars and back. It is very exciting to show up every day when we're talking about getting people to and from Mars, and that's an everyday conversation at the department. And at SpaceX, they are part of the rocket engines. They have been, and they're expanding their 3D printing production capacity for making rocket components, engine components that are being used today for space launches and their particular equipment. I will make a little bit of a side comment about America and so on that I got a perception of when I went to SpaceX and I saw their manufacturing line. So for those of you who haven't seen it online or so on, basically the main SpaceX manufacturing plant is it's very traditional, probably like Ford from 100 years ago. It's one building and everything happens into one building. And so aluminum comes in, rockets come out the back. And everything happens at the same building up front, and they're making spacesuits over there, and rocket engines over there, and Dragon space capsules. You can just see it, just walking through, and ultimately at the end, the rockets are there, and they roll them off on trucks. And up front is basically just up front of the building is just a whole giant area of just cubes, and they're design engineers who are 26, 27 years old, all recent graduates of Caltech and Carnegie Mellon, and so on, designing different components. And they're wearing T-shirts and skateboarding around, and eating pizza out of boxes, and a lot of them were wearing T-shirts that said "Occupy Mars." And so when you think about where we are as a country and a younger generation and being motivated with moonshots and exciting things to work on, there are exciting things to work on, right? I gave you my personal list, including space and the universe exploration. There's exciting things going on that are motivating people, and that's a great example of that. And so once again, and I'll give you a third one in terms of additive manufacturing. I was one of the fusion startup companies in which they were having to create basically a liquid metal, basically film around where the fusion containment would happen and the deuterium-tritium reaction would happen. And they have to kind of control this liquid metal blanket, that's the word, sorry, the blanket that they have on the outside of this containment. They needed basically a series of nozzles around the outside to kind of control that. And they're printing that with the help of General Electric. It's a unique piece of computer designed, never been, it's never been done before. Obviously, it's a fusion power plant that they're looking to build, and it's 3D printed because the ability to be able to build this very complicated and small nozzle system to control the liquid metal blanket is obviously unique, and the best way to do that was through basically modeling this and printing it from that. So these are things that could not be worked on at the levels that we're doing right now in terms of improved efficiency on aircraft engines, rocket engines to get us to the moon or Mars, right? Maybe actually making a fusion plant work, which by the way is actually a lot closer than I think a lot of people may know given some of the advances recently. So our ability here to connect with you all, because you all have the ideas, right? People here in this room, you all have the ideas. You all have the potential money to take a look and try to drive these. You see where the market is in a particular area in an application of carbon fiber technology or whatever you see that's going on here or elsewhere across the complex, and how to drive that forward. And the importance that these set of conferences is to create a set of connections that provide two-way communication, both us outbound to people here who see something interesting, who might see an application that you can go make some money on and help drive returns and help drive jobs and the economy. But it's the other way, which is everyone here in the room here from the National Lab Complex is about user-inspired research. So people here in the National Lab Complex sit down and talk with people about things they're working on and go, well, hey, we have those capabilities. Maybe we should be talking and maybe we should be driving some of our research and materials and in manufacturing that might have an applicability based on someone who you meet here today or you do follow-up. So we're very excited about all of that. The last thing that I would say about these conferences is that the National Lab Complex, we want to make certain that not only do we make an impact kind of broadly across the country, but also increasing the communication with our local communities and the development. There's a great degree of, obviously, a logical connection that if a company is starting up, it has a lot of advantages. It doesn't always have to be all of them, but certainly there's an advantage to being near where the innovation and research is happening. So if you're trying to produce a new product that is based on a certain material, certain process, could be batteries, once again, could be something on the manufacturing side is that there's a potential advantage to be located near where that innovation is happening because you could drive down the road, you can meet with a researcher who you've been working with for the last 6 months and come up with a new idea and drive it. And so this is, what would be, called, typical competitive advantage cluster theory, for those of you who are familiar with Michael Porter at Harvard. But, it's a well thought through kind of point, which is local communities become experts at whether it's media or finance, or Silicon Valley is an obvious example of a cluster, right, around technology, about how do we increase our dialogue not only across the whole country, but try to see if things can be built and built out in the local community. Obviously in this topic, right, around manufacturing, East Tennessee is a great example of a success story that is already a lot of things going on in terms of manufacturing, that they've been bringing in a lot of companies, including many from overseas, to be building things here. And a connection here with Oak Ridge is an example. But we're also working not only here, but we're having a lot of discussions about how it can be applied in Chicago, how it can be applied in New York, how it can be applied elsewhere in Denver and in Colorado. So our local connections is also important because, if there's capabilities at the lab, being near them as you drive a new product forward, we think has a lot of value. So hopefully that gives a little perspective of additional perspective beyond the Secretary and Undersecretary Menzies on different topics that we're dealing with. Thank you for participating in the dialogue. Hopefully you're making connections here today, whether you're at a lab or university with the private sector or vice versa. Hopefully people kind of come out of this with additional connections and hopefully drive follow-up. So thank you.